All right, thanks for joining us for the JRuby Jam. This is a follow-up to the Ruby Platform Options webinar we had last month at Engine Yard. And we're going to dive into JRuby more in depth. And joining me is Charles Nutter. Do you want to say hi?
Hey, everybody. Good to talk to you.
So just a couple of housekeeping notes. We're recording this event, and we'll post the URL to the video that you can watch later, probably in a week or two. And we'll also be posting slides on SlideShare later, so watch the Engine Yard Twitter account for those. If you have questions during the presentation, you can either post them in the Q&A panel in the WebEx application, or if you prefer, you can post something on Twitter and just tag your tweet with #JRuby, and we'll be looking for those as well. We can't promise we'll get to all the questions, but if we have such a volume of questions and good ideas, we'll try to follow up either with a blog post or online later and try to help you out with some of those questions. So one more time, could everybody just post a chat message in the chat and make sure that you're hearing us okay? I think we've already had a couple checks, so we should be okay. And once again, if you're having any audio difficulties, just post a message there, and we'll try to have someone help you out. So I guess we'll get ready with the main content of the presentation now, and Charlie, you can take it away.
Go, JRuby Jam. I think this is my first webinar, so this will be fun. We'll see how it goes. Let's jump right. I wanted to jump on the webinar. It was really just going to be Nick, but I jumped on to do a little JRuby overview just to kind of introduce people. I've been working on JRuby for a long time, and I love talking about all the fun stuff we can do. So we kind of get across the point that JRuby really is more than just Ruby plus Java. There's a lot more to it. And before I wanted to mention that we do have the Using JRuby book. A lot of the stuff that we'll talk about and cover here is in the book. It's been real helpful to a lot of JRuby users. So we recommend picking it up if you are interested in the book version of some of the stuff we're talking about. So the big thing when I go to Ruby conferences and talk about JRuby is kind of cover what's different about JRuby. JRuby is a Ruby implementation. We support the same libraries. We support 1.8 mode, 1.9 mode. We started to support C extensions. But there are things that make JRuby really unique, different among Ruby implementations. First of all, we'll be honest, and we'll get the bad, different things out of the way here. One of the bigs is that memory footprint is a little bit bigger. Some of this is due to the JVM being bigger. Some of it is also simply due to the fact that the JIT itself has stuff. The JRuby runtime has a little bit more logic in it for optimizing compilers and other stuff. So the base memory size for a JRuby-based application is going to be a little bit larger. Now, the footprint over time will generally be smaller. The JVM does a much better job of memory management. It's able to avoid a lot of the problems that plague applications that grow and bloat up to large sizes. So usually you'll do better on JRuby than you would with the standard implementation, just because we get JVM to help us out a lot there. Also related to memory footprint, objects in JRuby are larger. Depending on whether you're running in the 32-bit or 64-bit JVMs, they're going to be larger in both cases, probably quite a good bit larger in the 64-bit mode. But the actual structure of the objects does tend to be smaller. We do a little better job of packing instance variables into objects. And in general, the JVM also will pack in references and pointers and other stuff to try and make them as small as possible. So per object, usually a little bit larger, but if they're complex objects with a lot of instance variables, it can actually be a memory win. The missing or disabled features in JRuby as well, as many folks know. There is fork. This is asked for quite a bit. We would love to support it if we could, but the main problem with the standard Unix fork is that it doesn't pull any other threads along except for the thread that called it. The JVM starts up a lot of threads to do garbage collection, JIT compiling, signal handling, and none of those can get restarted on the other side because of the way the JVM is designed. So adding fork would be impossible for us on the standard JVM. It might be possible on other JVMs, but for now we simply just don't have fork, and there's no way that we can add it at the moment. We don't have continuation support. The call CC feature in Ruby requires being able to manipulate the call stack. JVM, all of that stuff is abstracted away so that it can do its own optimizations behind the scenes. There is no way currently on the JVM for us to support general continuations, meaning continuations you can save and call again from anywhere in your code. There are specific forms that work. if you do a call CC and only resume that continuation or jump back to that continuation downstream from the call CC block, but it still is fairly limited. And in general, we say we don't support continuations. There is prototype support for continuations in OpenJDK that we're working on, and hopefully that will pan out into something that's full-on JVM support for continuations or coroutines. Object space is off by default. The only way that JRuby can implement object space is by manually tracking every single Ruby object. As you can imagine, that makes a huge memory and performance hit. So in general, since object space is usually used for debugging purposes, it's off by default in JRuby. Easy to turn on either at runtime or by passing this -x+o flag, but it's something to keep in mind if you are using object space for something else. Func is another one. Trace func requires us to constantly ping to see if there's a trace func procedure installed to track line numbers, to track entering a method, exiting a method. And because of the overhead that imposes on us, we also have set trace func off by default. You can turn it on with --debug, again, a feature that's mostly used for debugging purposes and some interesting hacks. But in general, it's turned off, and if you need to use it, turn on debug. This also affects running, for example, Ruby debug. If you gem install Ruby debug, it does work on JRuby, but in order to do the debugging process, you need to turn debugging on. That we do have C extension support. We shipped it in JRuby 1.6. Tim Felgentreff did it for us as part of the Ruby Summer of Code, and since then we've slowly been trying to improve it and add more features. It does work, and a surprising number of gems function properly on JRuby with C extensions. But there are various aspects of C extensions that are kind of limiting for JRuby. For example, we can't run multiple JRubies in the same process because this extension doesn't know which one it's associated with. Concurrency is a problem. We can't guarantee the thread safety of any extension, so we have to lock on the way in and out. In general, the C extension support is experimental and kind of there to help you migrate. If there's one really tough extension that's keeping you from moving to JRuby, you can make a move today with that extension, try out for a while, and then maybe find a better alternative in the future. They are experimental, but we do intend to support them going forward. Now, with that stuff out of the way, we can go into some of the good, fun things about JRuby that make it a little bit different from other Ruby implementations. So first of all, getting started is pretty easy. You need to have a JVM installed. Snow Leopard and Down for OS 10 have a JVM built in. Lion and future versions don't have it pre-installed, but when you run Java applications, it'll prompt you to install it, and there is going to be an official JVM from Apple to the future. So it depends on your operating system. On Linux, apt-get will usually pick up one of the JDKs. There are RMs for what you can download from Oracle or from OpenJDK's site. It's very get it, and it just is a first step that you need before the rest of this. The rest of it's all pretty easy. The next is getting JRuby. The way we recommend is by using RVM. Most people that come to JRuby are already Ruby users, and RVM is the nicest way to manage multiple Ruby implementations. So here's what that looks like for anybody who hasn't ever used RVM, or at least used RVM to install JRuby. Install a little native launcher that comes along with this. We install Nailgun. Lots of the features that help make Ruby a nicer development environment will come out of the box, and RVM does a great job of pulling all that stuff in for us. So just go and download. We have binaries for various platforms. We have a Windows installer. We have an installer for OS 10 if you want to have it installed in a global location. You can pick those up, unpack it, as long as you got a JVM installed, and it'll just pretty much work. Ruby.org, you can see we got the various DMG, EXE for the installs, etc. Easy enough to go grab it and install it. No need generally for anybody to build their own JRuby. We just ship a binary that works pretty much on every platform. What's really nice about Ruby is some of the features we bring to Ruby itself. First of all, we do ship with Ruby 1.8.7 API and library support and 1.9.2 support right out of the box. You can take JRuby and run by default right now in 1.8.7 mode. You can see in the version string here for JRuby, it says Ruby 1.8.7 patch level is kind of equivalent. It points out where we are as far as 1.8.7 standard library. We ship it mostly unmodified. But if it's the --19 flag, it switches to 1.9 mode. And here we have an example using a very simple piece of code that only works in Ruby 1.9. You can see it doesn't run in the 1.8.7 mode, but you flip 1.9 on it and it works great. JRuby supports something called multi-VM. It really was never called multi-VM when we had this originally. I'm JVM. There's a whole lot to it. It's just an object. The JRuby runtime is an org JRuby Ruby object. We can construct multiple of them in the same process and can run multiple instances of the same app or multiple instances of different apps. So you really can have a single process that runs your entire site and potentially multiple sites without having all those processes to manage. Here's an example running the Trinidad server. Trinidad is a little embedded Tomcat, kind of equivalent to Mongrel or Unicorn or Passenger. And rather than spinning up multiple processes and managing them, we just spin up multiple JRuby runtimes. Here you see the default is that it will max out at 5 JRuby runtimes, so it would handle 5 concurrent requests in this mode. And it starts out by only starting 1, so it'll add more as it grows if necessary. You also run in thread safe mode, which then will run a single runtime, but it's nice to have the multi-VM feature available. So Ruby itself, solid across platforms. Ruby probably has the most consistent support for Ruby and compatibility across lots of different platforms. The big one would probably be Windows. People have said, I'll use some of the weasel words there, but it is true. People have said that JRuby may be the best Ruby on Windows. It runs consistently well. The performance is pretty much the same. Compatibility is the same. There's a few inconsistencies that we've tidied up. So whether the best Ruby on Windows or not, I'm not going to say, but it is a very solid and a very clean experience when running on Windows. For all on odd platforms like OpenVMS or ZLinux, JRuby also runs in those environments. There are people with production apps on some of the weirdest operating systems that I've ever dealt with. So you generally can expect that JRuby is going to work on whatever platform you need to run it on. If it can run on OpenVMS or AS400, it's probably be okay on your servers. The last big area that we get in JRuby is the fact we're running on top of the Java virtual machine, the JVM. JVM gives us lots of great stuff, obviously. The first would be the fact that we can call into Java or Scala, Groovy, Clojure libraries. All of the other JVM languages are just Java libraries, just JVM libraries to us. And you can call them from Ruby code as if they were just normal Ruby libraries. So a quick example. Anybody who's seen JRuby presentation in person will recognize this. This little script pulls in the Java library for Ruby code. And from on, we can access Java classes as if they were regular Ruby classes. Pull in new Java classes from the Swing package. Swing is basically the SDK's GUI library. Works across platform using the same API. Pull in a frame and a button. Construct a new frame and a button. Add an action listener. And notice that add action listener is taking a block. Normally in Java, this would have to be an instance of an action listener interface. But for many cases in JRuby, we allow you to just pass a block in as the body of that listener, as the body of that implementation. A button to the frame and show the frame. That's all there is to it. It makes libraries like Swing or many other JVM libraries much more fun to play with. When I find a new library I want to try out, I usually pull it to IRB and explore it a little bit that way. And then run code, and there you go. You got a little button, you click it, and it works. Entire Ruby cross-platform GUI development. Another example of doing cross-platform GUI development and making excellent use of all the libraries on the JVM is the Redcar text editor. Redcar is basically a TextMate clone written pretty much entirely in Ruby using SWT, another JVM GUI library, and a bunch of other libraries and tools to provide an entire editor environment. It supports Ruby, of course, but it also supports Groove and Clojure and a bunch of other languages. So check that out. Redcar editor is the thing you want to look for. Great example of using JRuby and providing an excellent hackable editor for Rubyists. Of course, the JVM's been around for quite a while. We have a lot of tools that have been built to support the JVM. Probably the most interesting one, or the easiest one to get into, is Visual VM. On most systems, if you have the JVM installed, you should have a JVisualVM command that you can start up. And do something like this. Off on the left there, you can see Visual VM actually recognizes JRuby applications that are running. This is actually a small Rails application running inside Trinidad. And the pane for Visual VM gives you basic information like CPU usage, memory usage. It'll list how many threads are active, and so on. There's a lot of panes that give you a lot more information now. For example, you can turn on the sampling profilers. Here's a memory sampler actually sampling a benchmark of that same Rails application. You can see by and large the objects being created are mostly byte arrays or character arrays, fairly typical, that string content is the main thing. But you can also see things like Ruby string objects. You can see some JRuby internals. It's also possible to see, down in this list, you'll actually see regular Ruby objects that will show up. And so you can monitor where all of the object allocation is going, where the performance is going, and use a tool that already is provided, JVM, to investigate memory issues. Another plugin for Visual VM is called Visual GC. If it seems like the application may be spending a lot of time pausing or spending a lot of time doing garbage collections, you can actually turn this on and monitor the garbage collection of the JVM real time. You can see the various memory spaces, the permanent space, old space, Eden space, all of the different areas that the JVM will allocate objects and do garbage collection, along with the CPU time, or the work time that's being spent to clean up objects into those spaces. Because being benchmarked, you can see there's a lot of sawtoothing here. The Eden space is chewing through a lot of objects. We've got some stuff sitting in the old generation, pretty much staying stable. That's mostly going to be Rails runtime and JRuby itself. But it's an excellent tool, an amazing tool, really, to investigate GC issues and try and explore what's actually happening inside your application. The JVM also gives us concurrent threading. It has had concurrent threads for over a decade, probably longer than that. And as a result, you get JRuby's native threading for free. So top of the JVM, and our Ruby thread is just a standard Java thread, which on all of the standard JVMs is an operating system thread, and you can actually get real concurrency. Here's a little test showing Ruby 1.9 running with two threads that are basically just turning an integer into a string as fast as they possibly can. Run in Ruby 1.9 or Ruby 1.8, you'll see that only about half of the CPU is used. No matter how many threads are running in Ruby 1.9, it will only allow one to run at a single time, because it has a global lock around all those. We run the same exact code in JRuby, and you can see we're almost saturating both processors. The little gap there is probably due to all the objects and GC and memory churn that we have going on. But you can get real concurrency across as many cores as you want just by using normal Ruby threading and any libraries that are built on top of it. The JVM really does have some of the best garbage collection. The vast majority of research that's gone into garbage collection over the past decade has been to support runtimes like JVM. And a lot of that work has meant the JVM has the best GCs, the fastest memory allocation algorithms. It's really the premier environment for memory. And we get them for free. If you've ever had any GC or memory problems on regular Ruby implementation, you can move to Ruby, and it's a good chance that the GC is going to have absolutely no trouble keeping up with it. It also has an optimizing JIT compiler built in. All we really need to do is emit JVM bytecode, and the JVM takes it from there. It'll optimize it, inline code, and turn it into what it believes is the fastest possible assembly code to feed to the machine. It means that in general, JRuby is, if not the fastest, then one of the fastest Ruby implementations, and it's just going to continue to get better with Java 7. Now that kind of gets me into the next little section here. A lot of folks have been asking what does the new invokedynamic support in Java 7 do for JRuby? So we'll actually take a few minutes and talk about that. Everybody done a little bit of Ruby knows that Ruby means method calls. There are tons and tons of method calls happening all the time, and that's the lingua franca of Ruby, is doing method calls. And if you want to run Ruby fast, that has to be fast right out of the gate. It has to be as fast as possible, or you're never going to get a fast implementation of Ruby. So in Ruby, here's a little simple contrived example code. We have these three methods, foo, bar, and baz, that just call each other in a chain. Foo bar, foo calls baz. What actually is happening behind the scenes in standard JRuby on Java 6, we've got a bunch of JRuby call logic in between each of these. Goes and looks up methods, caches things, makes sure that arguments are structured properly, that the number of arguments is appropriate, and then does the call. That all works very well, but unfortunately having all of our call logic in the middle of each of those call pipelines pulls a bunch of JVM optimizations. It doesn't know how to optimize through our code, it doesn't know what all this code means, and it certainly doesn't see that foo eventually is going to just call bar. There's just too many steps between there. The situation on Java 7 is completely different. All of the Ruby call logic disappears. Instead, invokedynamic and the method handle APIs in Java 7 allow us to explain to the JVM exactly how we need to do a dynamic call. All logic then gets sent directly to the JVM. It knows that foo is calling bar, and as a result, we end up with pretty much straight through invocation from foo to bar to baz to a Java library, to a Scala library, whatever. All of those things optimizing as if they were just normal static Java invocations. And that gives us amazing potential because standard JVM optimizations then work great on Ruby code. Inlining of Ruby code into Ruby code, Ruby into Java, Java into Ruby. You could conceivably have Ruby, Java, Scala, and Clojure code all inlined into the same unit and all optimized together. That's what we get out of Java 7, invokedynamic. And it's incredibly exciting how much easier it makes optimizing JRuby. And we're going to show a little bit about how much it's helping us and how much performance is improving just because we're starting to use invokedynamic. So let's take a look. I've gotten plenty of flack over using the fib bench to show JRuby performance, and it's fair. That's totally fair. The ability to calculate Fibonacci numbers fast doesn't actually mean anything. But fib is a good internal benchmark for implementers. There's lots of method calls. There's lots of math. Being able to run fib fast means that you're probably doing pretty well on low-level runtime performance. But in order to make it less contrived, less synthetic, I created a bench fib complex. What this does is it takes the standard fib and runs that, but it also runs the other versions. One uses an additional Ruby call before doing any of the add, subtract, and comparison operations, and one does constant lookups for all of the numbers. It actually has to go and do the full Ruby constant lookup, trying to pull in more Ruby logic and more Ruby overhead just to see how much that affects performance. This that I have in here is Richards, which is kind of a V simulator. It runs a bunch of things like polymorphic dispatch and a bunch of features that are difficult for VMs or languages to optimize. And it's a good example, a good test for sort of edge cases. Rather than the straight through, easy to optimize, easy to inline cases, it gives you a few other options, and you can see how they perform as well. And then more of a real-world benchmark, a red-black tree implementation that I swiped somebody. I'm sure the information's in the GitHub account or the GitHub project. It's a pure Ruby red-black tree implementation. And it just runs through, creates some big trees, walks them, and then benchmarks that whole process. So what does it look? Wait for it. Of course, these are benchmarks. If you don't like these, we would love to have your benchmarks. We'd have better benchmarks always, especially real-world ones from your own applications. Anything that we're going to come up with is by definition synthetic. So you're the ones that are going to be using JRuby. We'd like to see how your application performs and see if we can make it run faster for you. So here we go. The bar here is actually Ruby 193 Preview 1. I had available on my system. Bar is standard JRuby running on Java 6. And you can see that in general, JRuby does extremely well on performance compared to Ruby 1.9. This is without all of the JVM optimizations really kicking in. Any of this played with JRuby, you're getting this kind of performance in general, and I'm probably pretty happy with it. Now the interesting thing is when we have JRuby on Java 7. 7++ here because this is more of like an early preview, early update 2 to 7, which has some additional optimizations. Probably will be out in the next month or two. Single case, we get a substantial performance increase. Biggest ones here being, for example, fib with extra calls. Fib with constants drops down to almost free. The constant lookup's almost free compared to the normal fib. And the combined one, again, is only a little bit slower, maybe 30 to 50% slower than running regular fib. InvokeDynamic is helping us a lot here to eliminate all of the overhead of doing extra calls and constant lookups. Richer proves nearly 50%. Again, more code is able to optimize, more code is inlining. Black doesn't improve as much, but it does get some improvement. This one tends to be bottlenecked more on all of the objects that are being created. And of course, InvokeDynamic doesn't do a whole lot for us there, but Java 7 itself does a better job than Java 6 of optimizing object allocation, and of course, it has improvements to the garbage collector. All right, so with that, I'll hand it off to Nick, and I'll browse the questions on here and on Twitter. Thank you.
All right, thanks, Charlie. I'm just going to wait one more second while the host transfers control of the slides to me, and then I'll continue on. All right, there we go. All right, thank you very much. I want to shift focus now. Charlie did a great job of running really quickly through a wide swath of things related to JRuby as a general platform, kind of the ups and downs and the tooling and lots of the performance profile on a sort of a micro level. I want to step up to the level of a web application, which is, of course, near and dear to our hearts here at Engine Yard. And so I want to talk about deployment and tuning and some performance aspects in a little more detail than I have in the past. Some of this content might look a little bit familiar if you've seen some of our webinars before, but hopefully I can speak to it in a way that at least illuminates a couple new things. So make sure I have, there we go. So you may have seen this before. I had a blog post about JRuby web servers a few months ago, I think right before RailsConf, and you can go check that out and get some more in-depth information about what the different options are available to you. I like to think of the options for where you can deploy applications to with Ruby in these three essential columns, where you have a set of Ruby servers that behave much like Mongrel or Unicorn or other kinds of development servers that you might be used to from the Ruby world. You can deploy your applications as a WAR file, which you're probably used to if you're coming from a Java world, and you can use pretty much any Java server container under the sun to deploy those WAR files. Or you can deploy your applications to the cloud or to some platform as a service. And we allow you to do that here at Engine Yard. You can also do that with Google's App Engine, Amazon's Elastic Beanstalk, and Heroku, and a couple other options are out there as well. So I want to go quickly through a couple of different options and go a little bit more in depth. One of the servers that I really like that's come a long way in the past few months is TorqueBox. These are our friends over at JBoss and Red Hat, and they've been doing a lot of great work. And the reason why TorqueBox is really appealing, or it might be really appealing for you, is it's really unlike any other server product out there for Ruby or JRuby. And what TorqueBox really praises, or what TorqueBox allows you to do is it gives you a full stack of things that you can access all completely from Ruby code. So their version 2 product, which you can read about on torquebox.org, actually gives you a TorqueBox command line which you can use to deploy your apps and run your apps. And within those applications, not only can you have a standard Sinatra or Rails or Rack application, but you can do messaging and scheduling and background services all within plain Ruby code, and they're actually leveraging the JBoss application server under the hood. So if you are doing a lot of mixed Ruby and Java stuff, you can always drop down to plain Java and JBoss as well. So check out TorqueBox. Actually had a question from Bob on the TorqueBox team, who's on the call with us today, or at least watching from his comfort of his home, I'm sure. And he wanted to know when TorqueBox is available at Engine Yard. And Bob, I'll have to say that I'm getting more and more excited by TorqueBox by the day, and I hope we can work something out in the future. So we'll see how that goes. Moving on, I want to again briefly highlight Warbler. A lot of you probably have at least heard a little bit about Warbler, and this is the tool that you use to make Rails and Ruby applications run out of a WAR file in a server container. And the goal of Warbler all along has been simplicity. So you simply install it as a gem, and you get a warble command. It allows you to just run the warble command in the directory containing your application, and it'll create a WAR file for you. In this example here, again, I'm showing how you can modify the WAR file slightly by adding an executable component to it. This will actually install a embedded Java servlet container inside the WAR file that you can simply run with a jar file. So in addition to making Ruby applications run seamlessly in a Java servlet container, Warbler also allows you to distribute completely standalone Ruby applications that can be run on any Java virtual machine anywhere. So this is another option to look to if you're distributing Java applications and sending them to places where you don't necessarily have control of their deployment. And the brains behind Warbler is really this JRuby rack library, which is also a project under our JRuby umbrella over at GitHub. And you can think of it as basically a servlet to rack conversion layer. And the Warbler bundles this for you automatically in the WAR file and configures it for your Ruby application. And Trinidad actually makes use of this as well. And I'll be talking about Trinidad in a minute because, I'll be talking about Trinidad in just a moment. So JRuby rack, you can think of it as just like this. You have your servlet container. When the WAR file gets deployed, it looks at the deployment descriptor for the WAR file and sees that there's a JRuby rack servlet filter in there, so it wires that up. And then when the servlet filter gets initialized in the application, it will create an instance of your application and then talk to it through the rack API. So the last deployment option I want to talk about is our own App Cloud product, which is currently in beta. And what JRuby on App Cloud looks like is actually just the regular engine yard software distribution stack plus JRuby 1.6 plus Trinidad. And actually I also didn't on here, but if you go and look on our stack, we also include the most recent Java 6 JVM in the stack as well. I think Java 6 update 26 is what we have on the stack. So you can go check out the actual contents of our stack at that URL. And deployment on App Cloud with JRuby is really straightforward. You only need to make one small change to the gem file for your Ruby application and add the Trinidad gem. As I hinted at, Trinidad is actually the server that we're currently using on App Cloud to run JRuby applications. And when you deploy them, we automatically run bundler on your application and make sure all the gems are installed. And we need Trinidad to be there in order to actually run application with Trinidad. So you need to make that small addition. And then you have two options. You can either deploy your application from our dashboard, or you can deploy from the command line. And if you've ever used App Cloud, or if you haven't used App Cloud, the UI is pretty straightforward. There's just a couple screens for defining the Git repository where your application is deployed. It can be either a public one or a private one. You hook up a deploy key for accessing that repository. And then when you either deploy from the dashboard or the command line, App Cloud will go and pull the latest code from your Git repository and deploy that. It will run bundler on that code and then start up Trinidad with that code. I'll talk a little bit more about this later as I have some performance discussion around App Cloud. But for now, I want to go next to the topic of tuning, which is an often debated subject in JRuby since JRuby tends to differ in performance profile so much from your standard Ruby application. And of course, one caveat with tuning is that everybody's application is special and a unique little flower. So you need to take some of this advice with a grain of salt and know that in your case, some of these options may or may not apply, and you really need to look at the way your application is performing to determine what options are best for you. But we do have a number of standard recommendations that we typically steer people towards when we talk about tuning their application and making sure that it's running. First of these is that the JVM comes out of the box with a number of different just-in-time compilers. And the one that we recommend people use is called historically called the server compiler. And what this means is that the JVM the JVM server compiler does some aggressive optimizations, knowing that the code that it's running is going to be running for a long time, and the profile of that code will probably remain relatively constant over time. And so when you run with the server compiler, what happens is the startup time for the JVM will be a little bit slower, and the initial requests into your web application will also take a little bit of time. But within a few hundred requests, things will warm up to a reasonable level, and then within 1,000 to 10,000 requests, you'll even get a little more performance on top of that. So typically, when we hear from people that JRuby is running really slow, say, did you run with the server compiler, and then did you let it warm up? And warm up is really key to getting good performance out of the JVM. The next thing that's really important for pretty much any Ruby application running on JRuby is to make sure that you can run your application in thread-safe mode. And thread-safe, as you see here, is really an option that's specific to Rails. But you think about it in terms of any Ruby application that you want to run. The idea that makes this really hit home is that using a single runtime with many threads using it is much preferred to using a pool of runtimes. You can think about a sort of a connection pool, thread pool in your application server. Just threads waiting for requests to handle, and when those threads spin up and get an incoming request, if there's only a single runtime, each of them can run concurrently within that runtime, provided that all the code, Ruby code in that runtime, is aware of the possibility that multiple threads might be running. By contrast, the pooled runtime approach is basically saying, well, we don't know if the code in the runtime is thread safe, therefore we can only have one thread per runtime at a time. So if you have 10 concurrent requests, but only 5 available runtimes in a pool, you're not going to see nearly as much throughput. So the downside of not using thread safe is really damaging, because A, you're using several runtimes to do the work that maybe one time could do, which increases your memory footprint quite substantially. And then B, you're also limiting your throughput. So make sure you check out thread safe mode. The thing you're likely to run into once you've taken care of those first two items is the database pool. By default in Rails, the size of the connection pool is 5. Now normally with a regular Ruby application where you have process level concurrency, you don't really run into connection pooling issues because basically one process has one or maybe pretty much only one connection in use at a time. And then, of course, things like Passenger will scale by just spinning up multiple processes. Each process has a database connection, and so the default pool size of 5 doesn't really hit you when you're running in Ruby. But unfortunately, you move to JRuby in thread-safe mode. Now you've got a single runtime that many threads are using, and so you run into a problem right away if you have a database pool that has only 5 connections available, but you have a HTTP connection thread pool that has, say, 200 HTTP connections coming at you. So one thing you want to do right away is match the size of your database pool to the number of connections in your thread pool for your application server, so that you don't have any contention for database connections. And from here, there's a number of other things that you might need to look at. As I mentioned, the connection thread pool itself might be something to consider. If you find that you're getting a lot of high queuing times for requests, you might need to consider upping the number of connections that your app server runs. Another one, now we're getting into the area where with socket connections and database connections up in the hundreds each, we might be approaching the default open files limit on things like Linux, where typically you will only be able to have 1024 open files at a time. A lot of people say that that should be enough. You should be able to run an application with only 1,000 open files, but when you get a JVM running, you might want to consider bumping that up a bit. So open files can definitely be a blocker there. Once you've gotten through those, you might find that your application just needs more heap. By default, JRuby will give the JVM half a gigabyte of available heap. And the way the JVM manages memory is, of course, quite a bit different from Ruby. And the JVM always has a maximum heap size, and it will never go over that. and of course the reason for that is that the JVM never wants to, is architected and engineered such that it will never take down your system with a runaway process that has a memory leak. So if you have a memory leak, what will happen is when your application hits the max heap for the JVM, out-of-memory errors will start to be thrown, but the rest of your server will not be affected above that level, which is unlike what happens with runaway memory leaks in Ruby, where you need to use a process monitor to kill them after a certain memory size. And then finally, this is more of an advanced thing, but you can look at using different garbage collectors in the JVM. There's a number of extended options that will turn on different kinds of garbage collectors. And this gets more into the realm of black JVM magic. But if you want, you can pull out a tool like Charlie showed with the Visual GC plugin in the Visual VM tool and help that to kind of troubleshoot what your garbage collector is doing and possibly consider turning on one of these other collectors. But it really becomes an empirical process where you need to monitor and simulate production level traffic and see how the garbage collector behaves, and then swap out the different ones and watch that behavior and see if it improves things. Now I want to, for the last part of the presentation, I want to talk a little bit more about performance. And one of the questions we had on Twitter leading up to the webinar is that somebody was wondering what performance is like compared to something like Passenger. So I thought, well, hey, we've got JRuby on AppCloud in beta. We've got Passenger already supported on AppCloud. So let's fire up one instance each, one with JRuby, one with Passenger, and do some simple benchmarking and see what happens. And so what I did is I just set up a little static benchmark. This is nothing fancy. This is not like a load generator or any kind of real load simulator. This is just setting up the identical Rails application. I used a modified version of Redmine on a medium-sized EC2 instance running engineered AppCloud with MySQL. And you can see the Passenger Ruby Enterprise Edition, JRuby, and Trinidad versions there. And so this is probably the best possible situation for doing a static benchmark like this. We've got pretty much the identical surrounding environment, and I know it's identical because engineered provisions those instances identically across. And now the only thing we're changing is Passenger versus JRuby. And so for the static benchmark, I just set up a load generator to just hit the home page of the Redmine app in each, and I would step up the request rate linearly to see how each app responded. And so if we look at a scaling curve, this is what I actually observed. So you notice that the Passenger is in green, and Passenger is unsurprisingly scaling just fine up through 90 requests per second. Unfortunately, we hit a little bump with JRuby. Did I mention that JRuby is still in beta? Well, I thought it'd be prudent to not try to paper over the fact that JRuby still has some learning curve, and this is just a case of our AppCloud JRuby product just still being beta, and we still need to do some tuning of the default JRuby stack. What we see here is that up above 60 requests per second, JRuby is unfortunately falling into a catastrophic failure mode. But let's look behind the details a little bit and see if there's some more data that we can kind of pick apart. So Engineered also has the New Relic RPM product wired into AppCloud by default. So if you sign up for AppCloud, you also do get New Relic support built right in. So I was able to turn on New Relic for both our Passenger and JRuby apps here, and I grabbed a couple of graphs out of my New Relic dashboard. So what you see here is the average response time for the Passenger side of the app, and you can see as the request per second was stepped up, the response time does degrade just a little bit for Passenger. But overall, Passenger looks pretty healthy all the way up through the top of the benchmark. Now on the J side, we actually look pretty similar. You see that the average response time is a little bit higher than Passenger. Passenger hovered around 17 milliseconds. JRuby right now is hovering a little bit above 20 milliseconds, and it starts to get a little bit worse as we go on. But this, again, is a case of how long did you JVM warm up? I actually did not warm up to JVM extensively for this particular benchmark, but if I had done so, you might be able to see that those request latencies drop down below 20 milliseconds. We could probably eke out a few extra milliseconds and get pretty close to Passenger performance here. Now, this is just the first half of the JRuby response time. The other half, you can see here, we had the catastrophic failure, and now our response times are up in the seconds rather than milliseconds. And you can see that the previous page that I showed, those response times are no longer visible because they're so flat on this graph. So that's unfortunately that happened in this case for JRuby. But let's look at another aspect to this. Let's look at how the memory usage for these apps worked. So if we look at the passenger memory graph, we can see that passenger starts out relatively small and compact. But as we start to bump up the requests per second, passenger needs to launch more instances to be able to serve the concurrent requests. And so eventually passenger ends up kind of evening out around a little over 400 megabytes to be able to handle the volume of requests that are coming in. By contrast, JRuby starts out with a higher memory footprint, but even through the catastrophic failure segment, the memory footprint stays relatively flat at about 300 megabytes. And this really goes back to that point I made before about running in single runtime mode with thread safe and being able to handle all those requests concurrently with a single runtime. So this does show that I think there is some promise for JRuby here, and it's assuming that I can fix the catastrophic failure in configuration for App Cloud, we should be able to see JRuby scale up just as well as Passenger with less memory and a lot more tooling around it as well. All right, so just to recap some of the takeaways for what I talked about here. JRuby is pretty much speed for something resembling more of a real-world application. JRuby is definitely speed competitive with Passenger and other Rubies. Just showed the benchmarks before where JRuby was doing quite a bit better than the other Rubies. We find that when it comes to real-world applications, that doesn't necessarily translate right away. But again, we have to go back to the whole caveat about benchmarks where it depends on the application. As we saw in the memory graph, JRuby will tend to be make more efficient use of memory, and that typically comes with a little bit of a cost up front, but at higher throughput, it'll definitely pay off. And generally, we see that probably because threads are larger than processes. Even with Passenger's copy on write style strategy for trying to keep memory down, the memory does still grow above the level of JRuby, as we saw in those graphs. And then, of course, JRuby is at this point is still sort of a hands-on sort of a tool. I would say that JRuby is a product that you would use if you enjoy tinkering, if you like inspecting things, if you like looking under the hood and messing around. Passenger is definitely a good product, as we've seen. It worked well here, and I didn't have to touch anything. So if you're used to Passenger and you like not having to touch anything, hopefully a product like JRuby on App Cloud will be able to provide more out-of-the-box performance. But I think as we've seen JRuby, and certainly those of you familiar with the JVM in general, it does require a little bit more tuning and more working knowledge of your application to really get the best performance. All right, so that wraps up the technical content of the presentation. I just want to make a couple more public service announcements. You might have seen on Twitter that we have and our brand new JRuby blog, that we have some new JRuby t-shirts available. And if you go to blog.jruby.org, I don't have the URL on the slides here, but if you check out our new blog, we have a post about how you can get your hands on some of these t-shirts. I want to mention again that JRuby App Cloud is in beta, and you can try it on. You can start an App Cloud account, get 500 free compute hours, and try everything for yourself. And then finally, Java 1 is coming up in a couple of weeks at the beginning of October, and we're proud that we're going to be able to have a presence at Java 1. We'll have a booth. You can stop by and visit us, maybe grab some t-shirts. Charlie and myself and Tom should be by the booth on and off doing office hours, and we'll post about when we're going to be doing that, so you can come and talk to us about technical JRuby issues at Java 1. And we also have a number of talks at Java 1. I have a talk, Charlie and Tom have a talk, and Tom actually has a talk. I think we have 3 talks altogether. Is that right, Charlie? Is it 3 or 4?
I think so. Something like that.
Okay, and then there's also a talk by Mike and Jacob of Engineer, our cohorts who are in the product management team. They're going to talk about sort of Java in a platform as a service situation, so you can check that out as well. All right, so we've got 10 minutes left in our hour slot here. We can cover a bunch of the questions. I know we've got a number of them queued up. We'll try to go through them here. Let's see. Charlie, you said that you had a number of them. You messaged me. I think you have a number of them that you can cover. Do you want to just go down and we can kind of tag team them?
Yeah, and I'll go down the list here, and if there's any that look like you got a good answer for them, feel free to jump in. So starting with Chris White, what are the examples of popular C extensions that work with the CX support? Tim used a bunch of common libraries like Fin or YAGL or the native JSON gem. So things like that work. Most of the typical gems will install and work, the common ones. Some interesting ones that work are things like the native backend to event machine, which you might never use because the Java backend. I believe RMagic worked. What are some other fun ones? The servers are kind of weird. We want to find out what extensions don't work at this point. Some of them won't compile because we're missing some functions. Some of them will compile, but then there'll be a bug. But it's surprising how many work. Some of them are just bizarre that they function at all, like RMagic and some of those. That's some quick examples. There are a bunch that were used to test it, and we're looking for more that we can find issues to improve.
I just want to mention real quick that we do have a page on our JRuby wiki that lists sort of the converse of that question, which is which extensions are known not to work very well, and you can go check that out. And also feel free to add to that wiki page if you find other gems or libraries that are not working for you.
Right. Nick's JRuby Lint project actually uses this page to report where an application is ready for migration to JRuby. Scans through the list of extensions and alternatives and presents some messages to the user. So a good wiki page to update and to use as a reference. Daniel Gaiatino asks, are there any plans to update the profiler to be compatible with Google Perf tools so we can use their graphical mode? That would be great. I don't know what sort of output is necessary for perf tools, maybe something JSON-like, but there's no reason that we couldn't have the profiler output pretty much any format. The data is all there, and it's very easy for us to render it in any way. We just picked a format that was similar to, I think, RubyProf for the initial support in 1.6. Rogers wants to go into Nailgun a little more. Nailgun's essentially a little GM server that you can start JRuby in with RM installed. You can do JRuby -ng-server, which starts a background JRuby server process. Then JRuby commands that you run with JRuby or Ruby-ng will use that existing running JVM with a new JRuby instance inside it. This avoids a lot of the startup time that we would have from the JVM itself. It also allows JRuby's code to be in the same JVM a lot longer. So things can tend to run a little bit faster and sometimes can get down as fast or almost faster than Ruby 1.9. So if you're doing small commands, Nailgun's a nice way to run them. Daniel again asks, we run a highly concurrent system processing greater than 20K requests every second. Is the default GC recommended, or should we explore others? The general rule of thumb running on the JVM is that you see how it works first with the defaults. The defaults in, for example, the server mode are set up for a vast majority of cases. The typical case usually run very well on that. If you need better GC or you need to tune other things, then you proceed from there. You may want to go from the standard parallel garbage collector, which uses multiple threads to do its work, to the concurrent collector, which tries to do as much as possible while the application is running, or the D1 collector, which doesn't have as much copying and heap management as some of the other garbage collectors. So the options are out there. It's pretty easy to switch and see if they help your application out, but in general, try it out first and see how it looks. And tools like Visual GC or Visual VM to see if GC is actually the problem. Daniel again asks, is JRuby on Java 7 production ready? Features require JRuby 1.7. What's the ETA? We've been waiting for Java 7 to have its first update release, which will have a bunch of optimizations for invokedynamic, a bunch of invokedynamic bug fixes. Once that's out, then shortly after that, we will look at doing a JRuby 1.7 release that takes advantage of those features. We thought it was better to wait until Java 7 has really baked and has had at least one update before we do the JRuby 1.7 release and start talking about the combination of the two together. Chris Weiss, how were the benchmarks timed? They were simple. Most of these were simple benchmark library. So that's all there was to it. It did not include anything like startup, but of course these ran for quite a bit longer than startup would make a difference anyway. Daniela asks, I take it there isn't a GIL. Does this cause issues with existing Ruby libraries not playing well with threads? That is definitely a problem. It's much less of a problem now than it was 2 or 3 years ago. Hopefully the history books will credit JRuby as forcing groups to consider thread safety in their libraries because it's much more prominent in people's minds these days. And as a result, there are fewer libraries that have threading issues. We do run into them, and in a lot of cases, it's threading issues that might have hit you on regular Ruby if you're even using its regular guild Ruby threads. These are issues that just should be fixed in the libraries to begin with, but it's improving steadily over time. Pedro asks, I've seen some encoding issues on JRuby 1.9 mode, especially 1.9 mode. What is the best way to debug those? So first of all, JRuby 1.9 support is pretty good. The areas that we know are still a little weak are the encoding stuff. And with JRuby 1.6 dot release, we've been improving that and trying to get closer and closer to compatibility with all of the aspects of encoding. It's very complex, though, and we're looking for feedback from users to help us improve that. If there's something that doesn't work right or something that works differently and could cause a problem, we want to know. You can hunt us down on Twitter, talk to the JRuby account or any of our individual accounts. If you have an actual bug, we would love to have a bug report in our JIRA, our bug tracker, which is at bugs.jruby.org. And for going back and forth and figuring out whether it's a bug and how to fix it, usually there's some available on IRC, or you can email any of us anytime. Dave He asks about, with Warbler, do you need the JRuby jar as well, or is it bundled together? Warbler's in all of the dependencies that it knows about, and obviously JRuby is one of those dependencies. It'll also look at your gem file and whatnot, and try and have everything already built in to the Warbler file so that all you ship is that one file to production or that one file to someone who's going to run it with the Java command, and you've got a full running server, a full application without anything else required. Single file deploys anywhere. Jason Rod asks about layering other Java servlet filters on top or in front of JRuby Rack servlet filter. That's definitely possible. LinkedIn runs a number of sites on JRuby and uses exactly this mechanism for combining JRuby and Ruby-based, Sinatra-based applications with standard Java servlet pages or other libraries. So it fits very well, and the fact that we're using a filter allows us to be part of the normal pipeline of a servlet-based application. Chris asks, to what magnitude do open files limit generally need to be increased? Again, this is going to be on a per application basis and a per system basis, depending on what the base number of file descriptors is. So it'll depend. If you run into something, it can easily be bumped up, but it's also something that, unless you're getting to a really heavily concurrent app with lots and lots of connections and files open, you may never actually see this. Another one from Chris. Average memory required for JRuby Rails apps. Is there a safe starting point like 512 or 1024 meg? Again, per application, but there are people who run a single JRuby thread-safe application in under 150 megabytes for an entire site. The larger the site is, the more memory it's going to require. If you're not running in thread-safe mode, each additional instance that's running in the same process will require more memory. So it's a vary, but usually you can get a typical application running in a single runtime under 200 meg, maybe under 150.
Yeah, quick comment from me on that. So you saw that the Redmine application was running with about 300 megs, and to get the, I think most decent site apps should definitely be able to get under 512, and it's more just a matter of how much code, how many gems, how much Ruby code are you actually executing in your application. That's really the only thing. I think the actual running of the application itself is not a huge contributor to memory.
Right, exactly. More questions. We only have a couple seconds here. Jason Rogers asks, is there any support coming for hooking up remote debuggers? I don't know why not. Anything that's built on top of the standard Ruby debugging stuff could be made remote. I don't know if any effort is being done for that. We're not working on that directly, but since we support the standard Ruby debug interface and APIs, it probably wouldn't be too difficult to do.
But you can always hook up your using a remote Java debugger as well. You just need to operate at a little bit lower level and understand how you need to dig into the internals of JRuby a little bit more to understand that. But that's certainly an option.
Right. I think done. There's two quick questions from Anil Wadgul. Is config thread safe a must for production deployment? We strongly recommend it. Again, you need to kind of vet the libraries and make sure they're thread safe or at least clean across threads. But it makes a tremendous difference in both performance and the amount of memory that's used.
Yeah, just comment that it depends on your application. Once again, if you just have a small intranet application where you don't need to worry about it, and it only gets a few requests per minute or per hour, then it probably doesn't matter as long as you don't mind a little bit of extra memory overhead. But otherwise, we pretty much almost universally recommend it.
There's one last question about JRuby on Google App Engine being out of date. Yes, it is, although JRuby 1.6.4 I think now is small enough that the Google App Engine limit on size is not going to be a problem. So it should be updated pretty soon. You should talk to the JRuby App Engine guys and see if they can get an update out. And I guess that's it for us.
So once again, thanks everybody for joining. We'll have a video out for this in a short while and slides very soon on SlideShare. So check out blog.engineer or the engineer.com blog, as well as the Engineer and JRuby accounts on Twitter. And thanks again for joining us today, and feel free to contact us online anytime. One final thing, we're going to be sending out a small survey in your email inboxes for all of you that registered for the event, so please check that out. We'd appreciate helping out with some of those questions and giving us some feedback. Thanks a lot, and talk to you all soon. Bye.